Data-defining denizens of Swift. It's Prof. G, and in this lesson we're going to thoroughly explore enums in Swift. We'll cover a host of topics, many of which aren't covered or that receive only limited coverage in the official Swift documentation. And we'll lay the groundwork for our Dungeon Dice app. Let's learn big! Now, even though we're building a simple app, we're going to be covering a lot of important concepts in Swift and Swift UI. And the first we'll cover is enums. Enum stands for enumeration, which is why some folks pronounce it enum. You'll probably hear me use both enum and enum. I was raised by Canadians in the state of New Jersey, so I'm destined to talk funny. Sorry about that. Anyway, an enum is a user-defined data type with a defined set of related values. These values could be anything you as the programmer decides, like directions in a video game, grades for a course, or days of the week. Now, since an enum is a type, the convention is to write them in upper camel case, just like other types, strings, doubles, views, and the convention is to use lower camel case for the individual cases inside the enum. Enums are super useful. If you set an enum, you can make sure that only a certain defined set of types is used. Use something outside that, and you'll get an error. And everything that you define will show up in code completion. You can also create enums that have an additional defined value known as a raw value in Swift, and that can contain additional data. For example, here are letter grades that also return a GPA value, a double, while here are the days of the week, which also return strings for the day abbreviations. As mentioned, enums show up in code completion, which is especially useful, for example, if you otherwise work with strings. By declaring an enum that's associated with a string, you can refer to that enum in code completion, and you'll never have to worry about mistyping a string value between double quotes. We'll also demonstrate some additional important concepts when using enums. For example, while raw values assigned to enums have to be unique, we'll learn how to use a computed property to get duplicate values from different enum cases, something you might want to do for, say, in this example of setting directional movement in a video game. And we'll also learn how to create enums with associated types. These are additional values you can store alongside enum cases, like these different values from different kinds of barcodes. And we'll learn how to write a method, a function that's part of the enum, that you can use to return all or part of the enum's associated values. Be sure to code along with all these examples. There's more big learning ahead. Enum style. So let's start Xcode, create a new playground. We won't use a project for this video, but we'll apply what we learn in a project in our next video. I'll create this playground named Enums, expand the window, and hide the navigator pane. And let's write our first enum. Assume we want to set up directions for a video game. There'll only be 4 directions, up, down, left, and right, so we'll use the keyword enum, lowercase, then give the enum a name. This is in essence a type, so we use upper camel case for types. We'll call our enum capital D direction. And this is a simple enum with no raw values, so we'll just add open and close curlies, and inside we use the case keyword, that's with lowercase, followed by the name of each of our enum cases. And the convention here is to use the lower camel case for each of the cases, so between the curlies we write case up, case down, case right, and case left. Now don't confuse this with the switch case statements. Those case statements need colons at the end. There are no colons at the end of the enum cases. And now that we've defined this, we can now use that enum in code. So we can declare a variable to hold an enum case like this. Var latest move equals, then state the type we want to use with capital D direction. See that in code completion? There's a little e to the left indicating that this is an enum, followed by a dot. And look at that, all 4 enum cases that we defined pop up ready for our selection. Code completion makes this easy. I'll select dot down. But if the user force types a case in here that's not listed, Xcode will generate an error, so your code will never run with an invalid case for your enum. Then if we want to refer to latest move, we can just refer to the variable like this. Print, then the string the last move was, comma, latest move. Shift return, and we see in the console that the latest move was down. Now I wrote a comma in this print statement. Prints will print non-string values with strings if they're separated by commas, but if I try to combine the enum with a string, like in this line below, print, then the string last move was, plus latest move, my variable, Xcode says I can't do this because I'm trying to combine 2 types that aren't the same. The string, last move was, and latest move, which is not a string, it's a direction type, the enum that we just created. See if I option click on latest move? Xcode says this is a direction type, this guy up here. But you can always use string interpolation and pass in the enum like this, and this prints out the result as expected. Now maybe you want the result to be capitalized. Well, since string interp returns a string, you can just use the dot capitalized property at the end of this string, shift return, and we see that case is capitalized. Nice! And also note that because latest move has already been defined as a direction type, the next time I try to set latest move equal to something, I can just use dot notation without having to add capital D direction in front of it, and code completion automatically knows to present me with just the cases that are part of direction. And this is exactly how Xcode presents other predefined types like colors or button styles in code completion. Now you're setting up your own predefined cases in your custom enums. Cool. Also note that you can write less code by putting all case definitions on a single line like this. This isn't a very complex enum, so this notation is totally valid. Now I'm going to comment out the work that I've done so far, so I minimize what prints out in the console. And now let's create a new enum. This time we're going to assign values to each case. We'll call this enum move, so we'll enter enum, capital M move, and since we're going to assign values to each case, these are called rawValues in Swift, then we need to follow the enum's name with a colon, and then the name of the type that we're going to be using for the rawValues. So in this example, each case that we create will also have a string assigned to it, so we'll say colon string with a capital S, open and close curlies, then I just add an equal, and then the value after each case statement like this. Case up equals the string north, capital N, case down equals the string south, case right equals the string east, and case left equals the string west. Then I can use this in code completion like this. I can say var, declaring the variable named player move, and here's another way I can set this up. If I say colon, then indicate the type, capital M move, then say equal sign and dot, code completion knows that I've already defined this as a move, so it shows me just those predefined cases. Again, just another way of showing cases in code completion when you first declare and initialize a variable. Now under this I can say print, passing in player move, shift return shows me that this is the case right, but if I follow this with a comma, player move dot, notice that code completion now gives me an option to add a raw value. It also indicates this is a string. I'll press return to select this, shift return, and I see the raw value is printed as well, and that's the string capital E east. Cool. And to confirm, if you option click on player move, this shows you that this is indeed of type move. And here's something that sometimes happens. If I option click on raw value, for some reason Xcode isn't showing me that this is a string. It should, but there is a Swift statement that you can use to return the type of any value that you pass into it. It's the type function, and let's use that in a print statement right now. We'll say print, and in parens, we'll enter the word type, lowercase t. Notice code completion says this is a function. It returns the type of a value. Press return to select it, and for this of value here, we pass in any value that we want to get the type of. The capital T in here just says that it'll accept a value of any type. Swift refers to functions that will accept multiple types like this as generics, which is a topic for another lesson. But I'm going to enter playerMove.rawValue, shift return. In the console, we see the type string prints out with a capital S, indicating that our raw value for player type is indeed a string. So now you know about the type function. Now I'll highlight what we just coded, copy it, then comment it out with a command /, and I'll paste the code below so I can modify it. Let's have it hold a different value. How about integers, 1 through 4, for each of these cases? But note, if I do this, I get an error. Oh yeah, move was declared as a string type, but I entered integers for each of the cases. But I can just change string to int, then shift return. My code works great, and I'm returning a raw value 3 for the case right. Nice! Now, this is important. Swift requires that all raw values are unique, and we satisfy that case here with the values 1 through 4. But what if you were writing a video game, and you wanted, say, each move to change an object's coordinates, which might be 1 for a move up or a move right, but -1 for a move left or down? And actually, as I think about this, in iOS the origin 00 is in the top left, so if this were an iOS game, I suppose that I should have made up -1 and down 1, but this is just an example. Now we see if we entered these values, Xcode is going to protest that raw value is not unique. So how can I fix this pretty common usage case? Well, we can define just the simple cases without raw values, and I can even put them on a single line like this. But below that, we're going to use a technique that we haven't seen before in our lessons. It's called the computed property. Now, while variables and constants that we've been using up until now store a value, we set them to be equal to something, a computed property does not have a stored value. So we don't use the equal sign in here. Instead, it computes a property based on code that follows in curly braces. And here's how we set this up. We'll call our computed property value with a lowercase v. And it's going to return an int. So we'll start out declaring it like we would any other property that's not being initialized. We'll say var value colon int with a capital I. But then we follow this with curly braces, a closure. And in here we'll write any code that we want to use to compute and return what should be inside of the value variable. By the way, there are more advanced forms of computed properties involving what are called setters to set a property's value. This is a read-only computed property, no setter to set the value. We're just getting the value we're using. Getters and setters are for another lesson. And in here, I'm going to put in a switch statement. Now, what do I want to switch on? Well, I'm going to follow this with the keyword self in lowercase. Now, self here means that I'm referring to some case of the move type. Since this closure is inside of move, so I'm referring to move itself. Then in between the curlies of the switch statement, I'll refer to all possible cases that might be part of this move value. So case.up, and this is a switch case. So in these cases, I have to add a colon after the case statement. Then case.down, case.right, and case.left. And for a computed property, you have to return a value. This is the value that goes inside the variable we're creating. And in this case, this is what's going to be inside the value property if we ever refer to a move enums dot value. So we'll have a value for each case. If it's up, we'll return 1, down, return -1, right, return 1, left, return -1. And by the way, there's a shorthand that I can use here too. Since up and right return the same thing, I can say case.up, .right, that'll return the integer 1 for either case up or right, and I can do the same following case down with .left. Then I can delete these other two case statements so my case statement isn't so long. And now let's use this in our code. Now instead of referring to playerMove.rawValue, I'm going to change that to .value. Notice that .value now shows up in code completion. So return to select that, shift return down below. I get the value I assigned to the case statement, which is 1. Very cool. And if I reassign playerMove to .left, .down, back to .up, I see in each of these cases the expected value from the computed property is showing up as it's returned from the switch case statement that I wrote between the curlies. Now you know about computed properties. There are lots of other uses for computed properties too, and we'll definitely be seeing these in future lessons. So with that concept down, I'll highlight the code we just wrote, Command/ to comment it out, and let's create a new enum to hold ordinal values. These are the named values for numeric rankings, so we'll say enum, capital O, ordinal, open and close curlies, and then case, and all on one line. The different cases will be first, second, third, fourth, fifth, sixth, seventh. Now we already know we can use the enum like this, and be sure you enter with me since repetition always helps learning. We'll create a variable var, gens place equals capital O ordinal dot second, and we can print gens place, and we see second in the console just as expected. But if I want to add raw values to each of these, all I need to do is say equal 1 after the first value before the first comma. That's the first of my case values, and all other cases after this will receive the next number for their raw value in order. Second will be 2, all the way through seventh is 7. And of course, if I try to modify my print statement with comma, gens place dot, and look for raw value, the reason it's not showing up is because I didn't enter a colon and the type of the raw value after the enum case, because we're adding a raw value here, so I need to add colon int after ordinal. So if I type a dot after the second gens place, now I see raw value. I'll accept this and shift return to re-execute my code, and I see that both second and 2 show up in the console. Cool. So this cuts down on typing when creating certain types of enums. This technique is referred to as implicitly assigning raw values. Now we can change gens place to another value like sixth. We see sixth and 6 in the console. Back to second. Good. Now sometimes with enums, you might want to go through all of the values in an enumeration, or as we would say with arrays, we want to iterate through all of the values. Well, we can do this with a modification. We simply have to follow the name of the enum with a colon, but since we already have a colon for the raw value int here, then we follow int with a comma, and after the comma, we write CaseIterable. Upper camel case. Code completion says this is a type that provides a collection of all of its values, so the kinds of things that apply to collection type, many of the things that apply to arrays, will now apply to our ordinal enum. Now in Swift, we say that this conforms the ordinal enum to the CaseIterable protocol. It just states explicitly that this enumeration is going to follow all of the rules that are associated with CaseIterable values, so we can iterate through them. Now sometimes we're going to use colon and then list the protocol name, like CaseIterable here, but with different protocols, and those might require us to add certain functions, for example, or use certain variables, but none of that is needed here. Also, you have to do this if you want to do any of the collection iteration features I'm about to show you, because enums are not case-iterable by default. So let's try out a few of these case-iterable features. If you want to loop through all of the values in an enum that's case-iterable, we can say, in our case, for, in this case, why don't we say place, although we could use any value for the constant in here, then in, capital O ordinal, which is the name of our enum, followed by dot, and then all cases in lower camel case. Then open and close curlies, and this works just like it would if you iterated through an array. So we can say print, and then in quotes, To come in string interp passing in place means you came in position number, string interp passing in place.rawValue. Shift return, and we see the results in the console just as we'd hoped. Each of those values has a print line, 1st through 7th. Now, if you modify the original ordinal type, which you can't do programmatically while your code is running, making enums very type safe, they're like constants, and in this example we'll add cases for 8th, 9th, and 10th, shift return, we iterate through all the cases through 10th, we see all the numbers through 10 are assigned to the raw values using that implicit assignment technique we just added. Cool! Now here's another example. I'm a runner, but very notoriously an extremely slow runner. I'm always one of those tubby shuffling guys that's at the back of the pack. So we can say var profg place equals ordinal.10th, which is last place. The only time I was grateful for being a slow runner was when I was running the Boston Marathon the day of the bombing, and the race was stopped when I was at mile 22. Boston College, where I teach, is at mile 21. Watching the students help runners that day was amazingly heartwarming, as terrible as that day was. But you're not here to learn about that, you're here to learn about enums. So here's another technique you can use to show how many values are in an enum. We can say print profg was in string interp place. This was position string interp of string interp, and in the first string interp we'll put in profg place. The second string interp we'll put in profg.rawValue, and in the last one, this is the new one, we'll put in ordinal, capital O, the name of our enum, dot all cases, lower camel case, dot count, shift return, and I came in 10th place, which is 10 of 10. But if that enum was modified, adding an 11th case, run it again, now I came in 10th place, which is 10 of 11. Nice! So that's using enums that conform to CaseIterable. Now I'm going to highlight this code and command / to comment it out. Now let's create another enum example, this time for letter grades and grade point values. So we'll say enum capital G grades colon double, that's going to be the type of our raw values, open and close curlies, and in the United States, values assigned for letter grades are usually case A equals 4.0, case B equals 3.0, case C equals 2.0, case D equals 1.0, and case F equals 0.0. May you never earn one of those. Now I'm also noticing that for some reason Playgrounds isn't indenting my case values here. It should be, but I can just highlight the lines I want to indent, then press the Tab key to move that selection inward. By the way, this also works in the other direction. If you Shift Tab, you can remove an indent level. And then right underneath declaring this enum, I'm going to create a blank array of type grades. We'll call this student grades. Can you think how we do this? We'd say var student grades will be the name of this variable. Then we need to say colon, and square brackets, then enter capital G grades in between the square brackets. That's our enum. So we've just declared the variable student grades as an array of grades. Then we'll initialize this to an empty array, and we do that with equal sign, open and close square brackets. And the reason we need to declare this as bracket grade bracket as an array of type grade is because otherwise Xcode wouldn't know what values go inside this currently empty array. Then we can add values to this empty array. Let's assume this student starts out poorly but then really improves. So we'll say student grade dot append passing in dot C. Ooh, and look at that, I just had to press dot C. And that's because we already declared student grades as an array of grades. So Xcode knows we can only enter a grade element in here, so we don't have to put the type grades in front of this. Dot will only bring up cases of the grades enum. Then I'll add student grades dot append dot D, but we'll get better. Append dot B, append dot B, and append.a. Way to finish. And now let's calculate the grade point average, the average of all of these grades. Now there are other techniques we can use here, but we'll rely only on the ones we've learned up to this point in the course. We'll first declare a value to hold our sum, var sum, set this equal to 0.0. Remember, it's got to be a double because we're going to be adding double values. Then we'll use a for loop down below. We'll say for, and why don't we call our constant lowercase grade in student grades, open and close curlies. No need for CaseIterable here because we're iterating through an array now, not the enum itself. Arrays are already iterable by default. Then in between the curlies, we can say sum plus equal grade.rawValue. So that'll add things up. Then down below the for loop, if we want to print the average, we can write something like print, and then in quotes, the GPA, meaning grade point average, is string interp, and inside the string interp we can put a formula, sum divided by, and we can say student grades.count, but look at count in here in code completion. This returns an int. Now this is going to give us an error. We get the error here because we can't combine values of two different types. We're trying to divide a double by an int, two different types. That's a swift no-no. But the solution is simple. We simply wrap studentgrades.count in parens, then state the type double, capital D, out in front. That performs the type conversion from int to double. Now shift return. We see the GPA is 2.6. Still kind of low. Better luck next time. Now I'll highlight this last block of code we wrote, comment it out with a command /, and we're ready for our last example. And this will be an enum with associated values. And we'll also show how to access the individual parts of the associated values, which is actually, I don't believe, covered in Apple's docs, the core Swift manual, or any other tutorial that I could find online. So let's enter a comment stating that we're going to be covering associated values. And I'll actually start out with an example used in the Swift.org docs, but we'll go beyond the docs when we learn how to access the values. So here's the scoop with associated values. Sometimes you want to include cases with an enum, but also allow a user to add additional values that are associated with that type. So here's a great example from Swift.org. There are two major types of barcode formats. There's UPC, Universal Product Code, that's the barcode with the lines, and if you scan this with an iPhone or other scanning device, it returns 4 integers. Then there are also QR codes, and if this is scanned, it returns one big string. Well, we can create a barcode enum with both of these cases, one for UPC that allows us to enter 4 ints, and another case for QR codes that allows us to enter a string. Here's how we do that. We'll say enum, barcode capital B, curly braces, and then first we'll have case UPC, and then here's the new stuff. In parens, we're going to enter a format for the type of data that we want to associate or save with any value of this particular enum case. So in this case, we'll say inside of the parens, int, 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 int. This is going to allow us to capture 4 integers whenever we select this case of the barcode enum. Then on the next line, we'll say case QR code, lower camel case, and in parens, we'll say string. So if we declare a variable of type barcode, we can select if it's either .upc or .QR code. If it's .upc, we enter those 4 integers. If it's .QR code, we enter the string. Now there are some additional techniques we could use to limit input for more precise formats for these values, but we'll limit our simple example to just the 2 cases as they're outlined here. Now let's use the barcode enum that we just created to create a couple of constants. We'll say let Cheerios, barcode capital B, equals dot, and I'll select UPC here, and look at this coolness. I can enter 4 integers in here, tabbing between them, so I'll make up some nonsense numbers. I have no idea what the UPC for Cheerios is, but again, if I were to scan this with the iPhone camera or a scanning device, that would give me back 4 integers that I could pass into this. Then below this, let's declare another value. We'll say let Ilios Pizza, barcode capital B, equals dot. I'll select QR code this time, and this limits entry to a string, so I'll enter a nonsense string, but again, if you scan this and you were using the appropriate extensions to Swift, you could get the string that's associated with a QR code passed right into this value. Cool. Now on the next 2 lines, I'll print Cheerios and print Ilios Pizza, and I see how they print out, and they actually show the values embedded inside each of these 2 different cases. Now this is rarely useful. You often want to get the actual values inside the individual enum cases, meaning you want to look at the individual ints in the UPC or the code inside the QR code. Although, as a quick aside, if you wanted to check to see if the values were equal, you could compare values directly, but you'd have to conform the enum to what's called the equitable protocol by adding colon and then the word equitable, capital E, after the enum name. Here's an example of how to do that, and you could show, for example, in this case here, I've got 2 values. Even though they're different constants, they have the same QR code, which normally wouldn't occur. And here are 2 values that are different. If the data in the compared values were equal, I'd get true. If they weren't equal, I'd get false. But back to our example. How do I get the individual elements of a case? Well, we're going to add a function inside the enum to do this. And we say that a function that's part of an enum is going to be a method of that enum. So build this method for the barcode enum with me. We'll imagine that we want to return a string that's either made up of the 4 numbers of the UPC code combined and turned into a string, or the single string that's part of a QR code. And we want to return this as a string, not the barcode type. So in this example, we're inside the last curly brace of the enum. We're going to call this function func barcode string, open and close parens. We don't need to pass any values in here, but we are going to be returning a string, so we'll write the arrow symbol, then string with a capital S, and open and close curlies. Then inside we'll use a switch case statement to see if the value is either of the two cases in our barcode, UPC or QR code. So we're going to say switch, and then we'll switch on self. That's with a lowercase s, open and close curlies. Now self might look weird here, but this just means that we're referring to the value of the enum type barcode itself. We don't use a variable in here, we just use whatever data is inside the enum when we call this method, and you'll see what we mean in just a minute when we use it. Then inside I can say case.upc, and this gets a little tricky in here. If I want to extract 4 values from the 4 elements of the associated value, in parens I write let, so I'm going to be creating a constant, then follow that with the name of the constant I want to create. So I'll say v1, then comma let v2, comma let v3, comma let v4. I could have called these constants any valid constant name, but v1 through v4 is a fine choice. And always make sure that there's a colon at the end of case statements that are inside of a switch statement. Then I want to return these 4 values as a single string. So what I'm going to do here is simply say return, then in between double quotes, I'm going to put 4 string interps, passing in v1, v2, v3, and v4 into those 4 string interps. That's going to create a single string out of these 4 ints. Then down below this, I'm going to enter another case for QR code, saying case.QRCode, open parens. Again, I need to explicitly say let, then I need to specify a constant name that I'm going to use for the string value I'm going to get, so I'll just call this string value, lower camel case. Then below this, I'll just return string value. And see, I forgot my colon at the end of the case line here. I'm inside a switch statement, so I'll fix that, and that's it. And so now, let's see how we use this method. For any value of type barcode, we can simply say .barcode string after it, and regardless of whether it's a UPC with 4 ints or a QR code with string, it's going to return a single string with all of the case's data inside it. Let's try it. We'll say print Cheerios dot, and look at this. Barcode string shows up. That's the new method that we just created. It's now available automatically in code completion. Ultra cool, except this, Xcode automatically adds the parens at the end, which are required since this is a method, it's a function. And to think back on this method, when we wrote our function and referred to self, it's going to refer to the contents. In this example, that'll be the Cheerios barcode that's of case UPC. That's the data that's stored in this particular barcode enum type inside the Cheerios constant. Now on the next line, we'll do the same thing, print Elio's Pizza, dot, select barcode string from code completion, then shift enter down below, and will you look at that. When we printed these values earlier, we saw the types wrapped around the associated values, but we couldn't get at those associated values. But below, when we print using the barcode string method that we wrote, that method does get at the values inside because that's how we wrote that method. It returns the code as a single string for those values, regardless of whether it's the 4 ints of a UPC code or the single string of a QR code barcode. That's a very advanced topic, Swifter. Nice work. You learned a lot in our Enum lecture, including all the topics that you're seeing right here. I hope you're feeling skilled. Now let's finish up with a quick challenge that will apply in our project as we start building our app in the next lesson. So I'm an old-timer. I went to high school in the 80s, and also, not surprisingly, I was a nerd. Still am, and proud of it. Now, if you ever watch the Netflix show Stranger Things, or the exceptionally great but short-lived TV show Freaks and Geeks, you know that nerds in the 80s played Dungeons and Dragons. So this challenge is inspired by a favorite game of my youth. And if you know anything about that game, you know it's played with several kinds of multi-sided dice. So in this challenge, use a playground to create an enum named Dice. Include a case for each dice, or some would say the singular of dice is die, one for each die used in the game. There are 7 dice altogether, 4-sided, 6-sided, 8-sided, 10-sided, 12-sided, 20-sided, and 100-sided, which actually when you play the game is 2 10-sided dice, but we'll assume that you've got a single 100-sided dice for this example. And also assign an additional value to each case, which is the number that corresponds to the number of sides of a dice. So for example, you'll have a case for 4, which is the word for, F-O-U-R, but that also includes the number 4. Now create a method named roll that's part of this enum, and that when called will return a random number 1 through the number of sides of the dice rolled for the value that's in that enum. Give this a shot, Swifter, and we'll show the answer in the next lesson. Keep hacking!